Okay, so for the first example, you are given 4 members of a truss which are pin connected at joint O. The question asks you to find the magnitudes of force 1 and also force 2 for the system to be in equilibrium. Okay, whatever it is, the first thing you need to do is you have to draw the free body diagram, and then you have to establish the vector equation for every forces in the system. Then only you can apply the equilibrium condition. Okay, so let us start with the first force over here, which is force number 1. Okay, if we are to resolve it in the x direction, it will be going to the right, and the magnitude of the force would be F1, and since the 60-degree angle is right next to the line of force, so it will be F1 cos 60. Okay, so accordingly, if you are to resolve this F1 into the y direction, you will be going downward, and the magnitude will be F1 multiplied with sine 60. So if we are to rewrite this combination of x components and y components in vector form, our vector for the first equation would be, the first one is the magnitudes in the x direction, which is F1 multiplied with cos 60, and this is in the I direction. It's positive because it's pointed to the right. And the second one is F1 sine 60, since it is pointing downward, so it would be negative value in our equation, negative F1 sine 60, and this is in the j direction. Okay, accordingly, let us proceed with the second line of force, which is F2. So if we are to resolve this force in the x direction, it will be going to the right, and the magnitude will be F2. Okay, since the 80 degree is opposite to the line of F2, then it will be sine 80, and accordingly, if we resolve it in the y direction, it will be going upward, and the magnitude will be F2 multiplied with cos 80. Okay, so based on this combination, establish the vector equation for F2, by which F2 is equivalent to F2 sine 80, and this is in the direction of I, and then plus with F2 cos 80, so F2 cos 80, and this is in the direction of J. Okay, so 2 component forces are done. Let's move on to the third component, which is the 7 kilonewton. Let's call this 7 kilonewton as our F3. Okay, so if we are to resolve this 7 kilonewton in the x direction, will be pointing to the left, and the magnitude will be 7 multiplied with cos 30 degree, and in the y direction will be pointing upward, and the magnitude will be 7 multiplied with sine 30. Okay, so based on this combination, we can rewrite the vector form, by which F3 is equivalent to negative 7 cos 30, negative because it's pointing to the left, and this is in the direction of I hat, and the y component will be plus 7 sine 30, and this will be in the j direction. Okay, and last but not least, let us resolve this 5 kilonewton into the respective x and y direction. Let's call this 5 kilonewton as our F4. Okay, if I were to magnify it a bit, okay, given the small triangle over here, so let's just call this angle to be theta angle. So this theta angle will be equivalent to the angle over here. Okay, so if this 5 kilonewton is to be resolved in the x direction, you will be pointing to the left, and the magnitude will be 5 multiplied with, since the angle is opposite to the line, so it will be sine theta, and referring to this small triangle over here, sine theta will be opposite over hypotenuse, so it will be equivalent to 5 multiplied with 4 over 5, and then if we are to solve for this equation, 5 cancels out, so that leaves behind 4 kilonewton in the x direction. So accordingly, we have to resolve it in the y direction, so in the y direction will be pointing downward. Okay, so similarly, the magnitude will be 5 multiplied with cos theta, and based on the small triangle, our cos theta is equivalent to adjacent over hypotenuse, which is 3 over 5. If you are to solve this relationship, we get 3 kilonewton pointing downward. Okay, based on these two combination, you can rewrite the vector form of F4, by which F4 in vector form is equivalent to negative 4 in the direction of I, and then negative 3, which is in the direction of J. Okay, so now that we have established the vector vector form for all the component forces in the system, now only we can apply the equilibrium condition. So let me just copy these whole vectors into a new page so that it's easier for me to illustrate how we apply the equilibrium condition in the respective direction. Okay, so this is the vector form for all the four forces. So the next thing you need to do is, this time around, we are going to apply the equilibrium condition. So in equilibrium, okay, so let us start with all the components in the x direction. So assuming the rightward direction as positive, so in equilibrium, summation of all the forces in x should be equivalent to 0. So what is the components in x direction? So based on these vectors, so you extract all the x's magnitudes into one equation. Okay, so the first one is f1 cos 60, and then the second component of x direction is plus f2 sine 80, and then the third one is negative 7 cos 30, and then the fourth component in the x direction is negative 4, and that sums up to 0. Okay, so as you can see in this particular equation, you have two unknowns, which is your f1 and f2. So a good practice is that you leave the unknowns on the left side of the equation, and all the known value you transfer it to the other side of the equation. Okay, so this leaves behind f1 cos 60 plus f2 sine 80. So this one is equivalent to, take this whole lot to the other end of the equation, we get a value of 10.0622. Okay, so you cannot solve this because there is two unknown in this particular equation. So you just leave behind this equation, label it, we call it equation number 1. So if you start with something, you move on to the next equilibrium condition. So the next equilibrium condition that we can tackle is in the y direction. So assuming the upward direction as positive, summation of all the forces in y is equivalent to 0. This time around, you take out all the component forces in the y direction. So you have negative f1 sine 40, f2 cos 80, 7 sine 30, and also negative 3. Put it in one equation, by which negative f1 sine 60, and then plus f2 cos 80, and then plus 7 sine 30, and the last component is negative 3. So the summation of all these components should be equivalent to 0. Again, accordingly, as you can see, there are two unknowns in your equation. So leave the unknowns on the left side of the equation. So it will be negative f1 sine 60 plus f2 cos 80. So this is equivalent to, take this whole lot to the other end of the equation, you will get a value of negative 0.5. So again, you cannot solve it because there's two unknown in this equation. So let's call this equation number 2. Alright, so now if you look at your equation, you will notice the similarity. The unknowns is the same. F1, F1, you also need to find F2, F2. So you can actually combine equation 1 and equation 2 and solve it using simultaneous equation or persamaan serentak. So during your high school, probably you'll solve the simultaneous equation manually. So but since you are a degree students, so you should leverage the use of your scientific calculator to help you solve for the simultaneous equation. Okay, one key concept that you need to understand before we proceed solving the simultaneous equation using calculator is that you need to ensure that the structure of your equation is correct. So in order for you to use the parameters in the equation, so make sure your equation will be in this form. Okay, so you have two unknowns, which is x and also y. So this would be, these two x, y would be your unknowns, the value that you want to find. So in this case, our unknowns is actually f1 and f2. Okay, so the next thing is the variables attached to the unknown. Okay, the one attached to the first unknown is your a1. Okay, and the second variable attached to your second unknown is your b1. So this sums up to c1. This is from equation number 1. Okay, so accordingly, from the second equation, the structure of the equation should be x, y. This is the unknown that you want to find. So based on the second equation, the second variable attached to the first unknown is your a2, and then the one which is attached to the second unknown is your b2, and this is your c2. Sorry, I forgot, this should be c1. Okay, so make sure the structure of the equation is like this. Okay, then only you would understand what is a1, what is b1, what is c1. Okay, so matching this kind of structure with our particular equation. So as you can see, the f1 is your first unknown, so this is your x. The f2 is your second unknown, this is your y. Okay, so the first value connected to the first unknown, this is your a1. Sine 80 would be your b1, and 10.0622 would be your c1. Okay, accordingly over here, your a1 would be negative sine 60. Sorry, your a2 is negative sine 60. Your b2 would be cos 80, and negative 0.5 is actually your c2. Okay, now let us look at how we can access the simultaneous function in our calculator. Okay, now I'm putting the view side by side so that you can see clearly how the simultaneous function is being accessed through my calculator. So different calculator would have different features, so it depends on your calculator. So the common calculator is basically, in order for you to access the simultaneous equation mode, you have to press the mode function. So in my case, I press the mode 1, 2, 3 times until this particular display appears. So in this case, since I'm accessing the simultaneous equation function mode, I'm going to press 1. So you press 1, and the calculator will ask you how many unknowns is there in your equation. So based on your equation, based on our equation, we have two unknowns, which is the f1 and f2. So you key in 2. Okay, and immediately the calculator will ask you what's the value of a1. Okay, so referring to our equation, your a1 is actually cos 60, so you just key in cos 60, and then you press the sum button. You press the sum button, and the calculator will accordingly ask you what's the value of your b1. So b1 is actually sine 80. Okay, and then again you press the sum button. All right, and your value of c1 is 10.0622. 10.0622, and you press the sum button. So back to your a2. A2 is negative sine 60. Press the sum button. Okay, and then your b2 is cos 80. You key in cos 80. Press the sum button. And finally, your c2 is negative 0.5. You key in negative 0.5. So press the sum button. Okay, so automatically they will give you the value of your x. So this x, referring to our equation, referring to your equation, your x is actually f1, which is 2.3834. You have to press the sum button again. Okay, you have to press the sum button again, and then it will give you the value of your y. So based on our equation, your second unknown is our f2, which is 9.0073 is your second unknown. So basically, that's how you use your scientific calculator to solve the simultaneous equation for you. Okay, back to our answer sheet. Okay, the next step is using your calculator. You are actually solving this using your calculator. So you just write up using calculator so that I know that you are performing your calculations using your scientific calculator. Okay, using calculator. Okay, the x value, which is your f1, is equivalent to 2.4 kilonewton, and the f2 is actually 9.01 kilonewton. So as simple as that. Okay guys, for now I believe you can do this example on your own. So please do this example, submit it in ULearn, and I'll take your submission as the attendance for our online lecture today. And also please stay tuned for the next video where I am going to show you the example of equilibrium of particle in a 3D system. Stay tuned!